Hi everybody and welcome back to the channel. Today we're going to abuse SOLIDWORKS in order to create a part with infinite mass, and we will accomplish it with this. Thor's Hammer, Mjolnir, is of course Thor's primary implement that was forged by dwarves from the heart of a neutron star. Only those deemed worthy are able to lift it, but this model here has a mass, a finite one. This implies that a machine or being should be able to lift it if they can provide enough force, and that has nothing to do with worthiness. We can't have that, so I will make this model have infinite mass. If we're going to have this model in SOLIDWORKS, it might as well be canon. Now, you probably have questions like, why would you do this? And I don't have an answer for that, but what I am going to answer is how. How are we going to make Thor's hammer have infinite mass? Well, mass in SOLIDWORKS is calculated pretty simply, where it computes the volume of all the bodies and then multiplies it by the density of the material, assuming perfect homogeneity. So in order to drive the mass to infinity, we have to drive one of these factors to infinity and beyond. As far as I know, there's no way to make a part infinitely voluminous in SOLIDWORKS, so that leaves us with one factor, the density. So can we have an infinitely dense material in SOLIDWORKS? And like Bob the Builder would say, yes we can. We do this by abusing the C++ framework that SOLIDWORKS is built on and taking advantage of how it stores data. But before we do this, I will warn you, I will be using SOLIDWORKS in a way that it was not intended to be used, so if you want to try this, it will be at your own risk. It's basically essentially creating a file that has bad data, and while nothing severe happened in my testing, there's no telling what a file like this can do if the wrong system processes it. So be careful. At any rate, I'll perform the glitch for you, and then I'll break it down afterwards. So getting into SOLIDWORKS and going to Evaluate, Mass Properties, we can see that it indeed does have a mass, and a pretty lame one at that, 9 kilograms. I believe most people can lift that, so that's no good, so we're here to fix that. In order to have this hammer have infinite density, we're going to have to create a material, so you do that here. So I'll go Edit Material, and I'll scroll all the way down here where it says Custom Materials, and I could make a new folder, but I'm just going to throw in this custom plastic folder because I really don't care about it. So I'll right click and say New Material, and we can name it to whatever I want. I'm just gonna put a smiley face there because we're being a little mischievous here. Okay, so with this material created, I'm gonna go over to mass density here, and instead of a measly 1020 kilograms per cubic meter, I will paste this number, which is this really large number, and this one in particular has significance, but I'll go over that a little bit later. But I'll hit apply and close. And now you can see my material is just smiley face, as if it knows what's going to happen. If I go back to edit material, and if we go back to our custom material, check this out. Something very strange happened. It now just says INF for infinity, basically. So now that our infinite mass smiley face material has been applied, you'll notice that nothing really happens at first. SOLIDWORKS doesn't crash, doesn't explode, but strange things do happen, and if I go into the mass properties, you'll see that's where the weirdness, where all the weirdness is. So at infinite grams per cubic millimeter, we will of course have the mass at infinite grams. Also, pretty strangely, the pink little coordinate system that represents the center of mass is absent, and as well as all these moments of inertia, they all say 0. So it's pretty interesting because it looks like that SOLIDWORKS has a failsafe in here to prevent against this kind of bad data. At any rate, it's probably not good for me to keep this file around, so I'll probably delete it when I'm done. So what happened? The short answer is floating point numbers. I won't get too deep in the explanation because it's not my specialty, so if I find a good video that goes in depth, I'll put it as a card over here. But the short explanation is that a floating point number is a way of storing a number in software using bits in memory, say a 32-bit number. Using those finite 32 bits, we can only represent a limited amount of values within them. It's a lot of values, but finite nonetheless. SOLIDWORKS stores the density of a material in a double precision float, which occupies 64 bits in memory. and this number has a maximum value that a double precision float can take on. When entering this number, precision limits on floating point numbers take effect, and this number is rounded to infinity, which causes all this fun stuff to happen. Now, I don't blame SOLIDWORKS for having this exploit. You will never ever run into this in normal use. You'd have to be a real nerd to try and find an exploit like this. And now, before the video ends, I want to say that the model is actually not mine. I found it on the SOLIDWORKS tech blog, which is an awesome site if you want to learn some SOLIDWORKS. I'll put a link below. Well, at any rate, that's it. I hope you had some fun watching me do weird stuff with SOLIDWORKS. Don't forget to subscribe and hit the bell so you'll know when my next video comes out. So you have a good day, and I'll see you next time.